Hello everyone, let's solve some Leetcode today. So today we have Leetcode 703, that is kth largest element in a string. This problem is a heap problem because we have to find the kth largest element from the given elements. In this question, we actually have a university admissions going on and there people can actually submit their test scores in the real time. Now from those test scores, we actually have to find the kth highest test score in the real time, and this kth highest test score will be the cutoff for the interviews and admissions. So in the starting, we will be having an integer variable k and the nums array that contains the score, and we have to initialize this kth largest class with the integer k and the stream of test score nums. So it simply means we will be having random scores in the starting and we will have to heapify the scores so that we will have the kth largest element. And then we also have this add method. We will be adding test scores in the real time to the stream of scores, and each time we add a new score, we will again return the kth largest element in the pool of test score till now. We can easily solve this question with the help of a min-heap. So initially we will be having a k variable. Here the k is 3, and then we will be having a nums array initially. So this needs to be converted into a min heap, and then we will be adding new elements into the heap dynamically and return the kth highest score till then. So here the k is 3, and once we actually convert this particular array into a heap, we will have the 2 at the top because it is going to be a min heap, so we will always have 2 at the top. But the thing is that we need to return the kth largest element. So the kth largest element, that is the third largest element, is 8, 5, 4. 4 is the third largest element. So how do we make sure that each time we pop or we look into the heap, we are always getting this third or the kth largest element? We simply make sure that the size of the heap is always equals to k. If the size of the min heap is always equals to k, we know that we only have the k largest element in the heap. So how do we do this? Well, it's simple. You simply remove or pop the elements until the length of the heap remains k. So here in the array we have 4 elements. It means the size of the heap will be 4. So we keep on popping from the heap. So first the 2 will be popped, and then we have a size of 3. So the size of heap at this point will be 3, and it means that the topmost element in the heap will be the kth largest element. But some of you might be thinking, why are we using min heap? Why not just use max heap? And the reason is very simple. Understand that we are not supposed to return the largest element. If we use max heap, then 8 will be at the top, and then we will have actually 5, and then we will actually have 4. So it means that in order to get to the 4, we will need to pop 8, then we will need to pop 5, and then only we can actually access the 4. But that's not what we want, right? We need to access the minimum element out of the k largest elements, 8, 5, and 4 and 2. Out of them, the k largest elements is what? These. And from these k largest element, I want to return the minimum. So minimum is 4. That's why we are using the min heap. And when we restrict the size of the heap to this k, we are removing all the elements which are actually smaller than this particular 4. So all these elements will be removed or popped out. And that's how we will be able to get hold of this element. Now I hope you understand why we are using min heap and not max heap. So after initial configuration in the heap, we will have 4 at the top, then we will have 5, and then we will have 8. Now we have 3. The 3 will be added. So the 3 will come here at the top because it is min heap. But we see that the length of this thing becomes 4. It is not equals to k. So we will start removing elements. We will pop a 3. So the 3 is no longer on the heap, and we again have 4 on the top. Now let us try to put 5 here. So 5 will go here, and it is greater than 4. So the 5 will come somewhere here. 5 will be here between 4 and this 5, but it is again greater than k. So we pop the 4, so 4 is gone, and now the heap contains 5 and then 5 and then 8. It means the kth largest element till now is 5. So you will return 5. Now we have 10, so we will try to add it here, and the 10 will come at the bottom. And now the size again becomes greater than 3, so we will simply pop it, so 5 is gone, and now the kth largest element is still 5, so we will still return 5. So now we have 9, so 9 will go after 8, so the heap will be something like 5, 8, 9, and 10. And then after this, we again see that the heap actually became greater than k, so we will remove the 5 elements, and then the next kth greatest element is 8, so we will return 8. And then we have 4 here, so we will try to add 4. The 4 will come here, and then we see that this length again becomes greater than k, and k is 3, so we will simply pop the elements until the size of the heap becomes k, so 4 will be gone, and now again the kth largest element is 8, so we will return 8. That's how we actually solve this problem. Now let us go through the code also. So we have a heap heap variable here, which is normal array right now, and then we have a k variable here which contains 0. So these are the local variables that we are going to use in the functions, and here in the constructor of the class we are getting the input k and nums array. Now we will set the local heap to nums and local k to the k variable, and then we will use the heap queue module in the Python to heapify the self.heap array into a mini heap. Now in case the size of the heap is greater than k, we know that we have to pop the element. So that's what we are doing here. While the length of the heap is greater than k, we are popping the element. So this will be the constructor. This will initialize our kth largest class. So now we have the add function, and in this function we will be getting a value that we need to add, and we will be returning the value of the kth largest element or score till now. So first of all, I will push the value into the heap, and then I will make sure that the size of the heap does not become greater than k. So I have this while loop that will pop the elements until the size of the heap becomes k, and then I will simply return the top element of the heap without popping it. So now let's run it and see what happens. So it takes 4 milliseconds and beats 98.31% of the solutions on Leetcode. It's a pretty efficient solution then. Now let's look at the time and space complexity for this solution. And so the time complexity for this solution is order of log k, and that is because the heap never exceeds the size of k. So in the add function, we are first of all pushing a single value in the heap, and then we are making sure that the length of the heap remains k. But remember that we are pushing a single value in the heap. It means the size of the heap will actually become k plus 1 only. It means this particular thing will only pop once. So this while loop will only run one time. It means the add function depends on the time complexity of the heap push and heap pop functions, and the time complexity for heap push and heap pop is log of k. And here in the constructor we have this nums array, and the length of the nums array will only be k plus 1 at most. It is already stated in the constraints. It means this while loop will also run only a single time at most, and that is why the time complexity for the solution is order of log k. And now the space complexity is order of k, and that is because the heap never exceeds the k elements. So yeah, like the video, subscribe the channel. If you have some kind of question that you would like me to target, or you have some kind of topic that you would like me to talk about, then just let me know in the comments. Now we will meet in the next video. Till then, bye.